Hello, everyone. Welcome back to week 6, stream processing. Um, in the previous videos, we tried to consume and produce to Kafka using Java, but we use a lot of terminologies like partitions, retention, replication, all, consuming from latest or earliest, auto commit offset as a config, certain other configs, which we didn't define at that moment. And I think this is the right time to take a look into these configuration with a bit more detail, a bit more theoretical knowledge, because that's really going to help us in defining our architecture if we need to do that in the future or how. Hello. So let's first define what is a Kafka cluster. So Kafka cluster is nothing but nodes or machines talking to each other. So let's assume we have 3 nodes which are running Kafka. So all of them are running Kafka, and they basically are in a network. They are talking to each other, and that's basically what is called a Kafka cluster. So whenever anybody is talking about Kafka cluster, it's nothing but different machines running Kafka, and they are talking together using some sort of communication protocol. Earlier, Kafka used Zookeeper for communication, and Zookeeper was basically used for topics. So what kind of topics exist, what kind of topics have been created, what are the partitions or the retention for the topic, and all that. Now that's not there anymore. So Kafka now doesn't use Zookeeper at all. It uses Kafka's internals. So basically it uses a topic, and that topic itself stores all the information about the topic, about the partition, the replication, and that topic is being used by different nodes to basically communicate with each other. And that's basically it. Let's next define a topic. We already defined it. A topic is nothing but a sequence of events coming in. We ourselves define a topic. So in our case, we defined a topic of rights, and we said that this topic will contain all the information for ride. So in our case, the ride had a key of vendor ID, but this can be basically anything. And the value was basically what that ride consisted. So basically, where was the pickup, where was the drop off, what was the final price, and other information like that. So that was basically a JSON string, and we had that as a value. Another thing which we talked about was basically timestamp. And the timestamp was nothing but a long, which kind of defined when the event was produced or when the event was actually seen by Kafka. These things together formed our message, and message is nothing but the actual event which is released by our Kafka producer. So whenever a producer is producing to Kafka, it's talking in terms of events or messages. All right. So we already talked about Kafka cluster. Let's talk about how a Kafka provides reliability in Kafka. Basically, we have our nodes, so we already talked about them. Let's assume that we have a cluster with 3 nodes. These 3 nodes are basically communicating to each other to form the sort of Kafka cluster, which we talk about. And then we have one topic, right? So we have our topic, and that topic was basically for us rights. So let's name that rights. This topic would exist on one of the clusters, right? So this topic, let's say, exists on node 1. So let's name this node. Okay, so node 0, node 1, and node 2. And this topic is basically stored on one of the topics, on one of the nodes, basically, in this case, node 1. So what happens if node 1 goes down? If node 1 goes down, the cluster will rebalance, and now the cluster would only have node 0 and node 2, but the topic itself is gone. And any consumers or producers who were producing to this topic would not be able to do that anymore. Why won't they be able to do that? Because the topic does not exist for Kafka cluster anymore. The nodes of Kafka do not know that the topic exists. So before this node existed, what was happening was basically your producer was talking to node 0 or node 1, sorry, and your consumers were also talking to node 1, and they were basically communicating to each other. But now in this case, they basically cannot do anything because the node 1 itself is down and the topic is gone. So that's where the concept of replication comes in. And what replication means is that we have our nodes again, and we have our topic. So we have our topic inside, and we replicate this topic. So the concept is replication. And then we say, okay, we want a replication of 2. And in this case, the topic will exist in both nodes. So our node 0 will also have the topic, node 1 will also have the topic, node 2 will also have the topic. Obviously, the nodes are talking to each other, and they are kind of keeping track of things. So for this particular topic, for the topic rides, there would be a selection of leader and slave. So let's say node 1 is basically leader, and then node 0 is follower for this particular topic itself. So for topic rides, node 0 is a follower, node 1 is a leader. And any communication which is happening, so any producer will talk to node 1. Basically, it will talk to the cluster, but then in the end, it will talk to node 1. And any consumer will basically also talk to node 1 for the topic rights. Whenever a producer produces a message to node 1, node 1 will basically, what node 1 will say, let me zoom in a bit more. Yeah, okay, so this is better. So node 1 will basically write the message in the logs itself, and this message will again be duplicated to node 0. So basically this message would then be duplicated to node 0. And the consumers will basically keep consuming from node 1. But if node 1 dies, basically it's dead. Both the producers and consumers will not note any difference. They might have a delay. They might have some, like maybe a few seconds where nothing is happening. But what will basically happen is consumers will directly connect to node 0 because it was a follower, and the producers will also directly just connect to node 0, and everything will start following. Again, the follower, this will be gone, and now this will become a leader. So this node is gone, so we don't care. This becomes a leader, and then Kafka realizes that, hey, you know what, this topic has only one replication, but I wanted 2 replications, so maybe it starts replicating the topic itself in node 2 later on. So basically, this step of replication would start. This depends upon how fast node 1 comes up, if it doesn't come up at all, and all that stuff. So this is basically the whole process of replication and how replication is handled internally inside Kafka. But it's very important for us to know the term, to know the understanding of replication.factor, which is a config we always set when we are setting up a topic. Okay, so basically what we are interested in this case is knowing the terminology of replication factor, which we will use a lot in our configuration. Another thing which we talked about while doing Kafka was basically retention. What basically retention means is how long the data will be retained by Kafka. So again, let's take the same example. We have our 3 clusters or 3 nodes, node 0, node 1, and node 2. And these nodes are basically talking to each other. And there is a topic right inside it. So the rights topic was stored in node 1 and node 0. But for how long do you want to really store that? Because you have limited amount of memory, you have limited amount of nodes, you really don't want to save everything forever. Let's assume that our rights topic is producing 1 million messages every few minutes, and that would be a lot of messages to keep forever. So there is a retention which we also set. If you remember when we created a topic, and the retention will basically delete anything which is older than whatever the retention you have set. So let's say we have set up a retention of 1 day. And what happens in that case is basically any message in this topic. So let's maybe zoom in a bit. So any message inside the topic itself, if it's older than 1 day, so let's say this message, let's say the last message we had was now older than 1 day. And what will happen in this case is this will get deleted automatically. And you don't have to do anything about this because you set up the retention as 1 day. So any message or any event which is now older than 1 day will just get chopped off. And that's basically easy to do in logs because you're doing only append only. So you just see, okay, this message is older than 1 day. So everything after that or before that was also older. So just chuck it out and remove it in one go. So this is basically the concept of retention. Let's look at another one or a very interesting one, which is basically partitions. So all right. So this is a very interesting one. Partition is what allows Kafka to scale. So now with partition, yes, we are also talking about how the data is stored. So let's first talk very quickly about how the data is stored. So again, we have node 0, node 1, node 2, and we had our topic stored in node 1 and node 0. But this topic only had one partition. So if we are partitioning our topic, what basically we are doing is we are taking our topic and we are dividing it into two. So if this was our topic rights, we set the partition is equal to 2. So what we are basically doing is we are dividing it into two different parts. So let's say we have our rights partition 0, and then we also have our, let's take a different color, let's see yellow, and then we have our same topic rights, but the partition is 1. So instead of having a big swim lane like the rights topic, we have now divided into two smaller ones. So how does it stores in the nodes itself? Let me make it a bit bigger. Let's redraw this one. So we have our nodes. So node 0, node 1, and node 2. And now we have partitions and a replication of 2. So the partitions are basically, let's say the partition 0 is stored here. The yellow color. Partition 1 is stored here. And now these two can communicate with the consumer separately. So now that's how basically you scale. But this same thing is also replicated across multiple ones. So let's maybe the partition 0 is replicated here, and the partition 1 is replicated here. So these two are basically nothing but replications, and they will only take impact if the leader is down. But before in our case, only one node can talk to the consumer, but now two nodes can talk to consumers. So their consumers might be able to split up and talk to different nodes at the same time. So let's take a concrete example about that. So earlier, what was happening was we had our rights topic, and the messages were coming in this topic. And this topic only had partition of 1. So we didn't have any partition of 1. So no partition at all, only messages are coming in. So one of the consumers started consuming from this particular topic. Everything is good, messages are coming in, the consumer is consuming. Let's say the messages size increased a lot and your consumer could not consume with the same speed. So your consumer maybe had to read the message, unpack it, maybe your machine was slow, maybe there was some other complicated call it had to do. Let's say the consumer was making an API call, which was taking 3 seconds to reply or something, and that becomes that, and that's, let's say this was sync. So now all kind of problems started popping up because you were not able to read the message with the same speed as you were reading before. An easy and obvious way we can actually solve this is by introducing our another consumer. So this was consumer 1. Now we introduced a consumer 2. And what we will assume is basically that half of the messages goes to consumer 1. So let's say there was messages like message here, maybe a yellow one. We would assume maybe the blue messages to go to consumer 1 and the green messages to go to consumer 2, or maybe also the yellow messages goes to consumer 2. But this is not how Kafka behaves. For one partition, only one consumer can connect to it. That's why we need to define multiple partitions if you want to scale. So let's take a look in how this happens when we partition our document. So again, we had our rides topic, and we want to partition it by 2. So 2 partitions. Let's make our first partition. So this would be partition 0. Then let's make our second partition. This is partition 1. All the blue messages goes in partition 0, and all the green messages goes in partition 1, just to make it easy. Let's say in our first case, as before, we only had one consumer, and consumer said to Kafka, hey, I want to read from rides topic, give me all the messages. What will happen in this case is basically consumer will connect to both partitions and will read from both the partitions simultaneously. So this was your consumer 1, but then again, because of the API, because of the 3-second delay, we start seeing some problems, and we thought we will scale this out. So how do we scale this out? We basically add another consumer. So we add a consumer 2. And what does this consumer do is basically this tells Kafka that, hey, you know what, I am a second consumer or a second replica of my consumer 1. I'm absolutely the same, so I can basically read the messages from your rights topic. And what will happen will be basically that one of the partitions, let's say the green partition, in this case gets assigned to consumer 2. And your consumer 1 basically is now reading only half of the messages, and the consumer 2 is basically reading the other half of the messages. How do Kafka know that these consumers belong to the same entity or the same group? And that's where something we call, let's take yellow, something we call consumer group ID comes into place. So if your consumers have the same consumer, or let me take a black one, have the same consumer group ID, basically the Kafka will understand that they belong to the same entity, and that's why they can basically partition. What happens now if you introduce a third consumer? Let's say you introduce another consumer 3. Basically nothing will happen because you only have 2 partitions, so you can only have 2 consumers consuming from it. But maybe what happens is that consumer 2 dies because of some reason. Let's say it was out of memory, maybe you just restarted the pod, the consumer 2 dies. What will happen is basically Kafka is smart enough to know that there were three consumers consuming from two partitions. So one of the consumer would be basically idling at this moment. So it will redirect the partition two messages to consumer three. That's basically how Kafka will scale out, but also build some sort of reliability. If you always want everything to be consumed as such, you might want to have an ideal consumer consuming for it, although that's not a pattern which is generally suggested. All right, now okay, this was a lot of talking. Let's talk about a few more topics before we end this. Let's talk about offsets. Now, we talked about partitions, we talked about messages being consumed from Kafka by consumers, but how does a consumer know which particular message to consume from? Or how does Kafka know that, hey, you know what, this consumer has already consumed message 10, now it only should consume message 11. And that's basically done using offsets. So let's go back to our topics. And in this case, we have the rights. So let's take rights. And then we have messages inside it, right? So there is an offset attached to each message, and that offset is basically 0, 1 to blah, 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 100. Whenever your consumer consumes from a particular topic, it also acknowledges back to Kafka that, hey, you know what, I have consumed this message. So let's assume this consumer consumed message 0 to 0, 1 to basically message 10. And what it will do is basically it will go to Kafka or your Kafka cluster, Kafka broker, whatever you want to call that, and say, hey, you know what, I have consumed, or let's name it better, I have commit message 10 or offset 10. What Kafka does is basically it stores this information. So it stores this information in another topic, which is called __ consumer _ offset topic. So this is itself a topic inside Kafka. It's an internal Kafka topic, basically. Let me just make this _ consumer _ offset. So what will happen is, let's say this consumer dies and then comes and reconnects to Kafka and introduces its consumer group ID. So everything has to be inside a particular consumer group ID. And basically, it will say, hey, you know what, this is my consumer group ID, and Kafka knows which consumer group ID from which topic consumed or committed how many messages. And it will say, hey, you know what, you have already committed 10 messages from rights topic. So start reading from the 11th message and onwards to 20, 25, 100, whatever the size is. And basically the consumer will do that. The consumer will say, okay, so somebody from my consumer group ID has already read these messages. So I'm not going to read them. I'm going to read from message 11. So how does it look inside the consumer offset? Basically, it's something like your consumer group ID, comma, topic, comma, partition, because we know that different consumers can consume from different partition, and which offset has it already committed. So basically these four information are stored inside the message of the _ consumer _ offset topic, and this kind of tells Kafka, or basically tells Kafka how to restart our consumer. And we also talked about one more thing in our last tutorial, which was basically the configuration auto offset reset. And I said there were two values which you can put here. One is basically latest, and the other one is earliest. So what is auto offset reset? So auto offset reset, sorry. So auto offset reset is basically nothing but a way to tell Kafka how to react when a new consumer group ID has been attached to it. So let's take the same example. We have our rides topic. The rides topic had offset from 0, 1 to 100 and a new consumer group ID. So basically, this is my consumer group ID. Let's call it Ankush consumer group ID 1. And then basically, I try to connect to Kafka and say, hey, you know what, I want to read the rides topic. But Kafka doesn't know what to do in this case because Kafka has not seen this consumer group ID before. So what it will do is basically it will use latest as the default. So latest is our default behavior. And it will say, right now, there are around 100 messages in the topic. So you consume from 101 whenever that comes in. So whenever there is a new message into rides, you will be able to read that message, but you would only be able to read that message from 101 offset. That's because you had the offset as latest. So whatever was the latest offset. Now, if I specifically and intentionally set something like earliest, I say, okay, my auto offset reset is earliest, and I try to connect to Kafka. When I try to connect to Kafka, it realizes that Ankush, let's change our consumer group ID in this case and name it to 2. So we have now renamed our consumer group ID. We have also added auto offset reset as the earliest. And what it will tell Kafka is basically give me the earliest message available to you. So in this case, the earliest message available is 0. So basically, whenever we connect to Kafka, in this case, it will say, okay, you are saying your auto offset reset is earliest. So the earliest message available is 0. So please consume messages from 0 offset and so on. And that was the reason we were not able to see any messages before, because we were using latest in our auto offset reset and we were not producing any more messages to that particular topic because our producers already kind of did their job and they ended. And because of that, we were not able to see any messages. As soon as we updated our consumer group ID and set the auto offset reset to earliest, it basically started consuming all the old messages which which existed in the topic itself. That's basically auto offset reset. All right, I promise this is the last one because we already covered this. So I want to finish this one up and just let's go through it. Acknowledgement all. This is from the producer side. This is also a really important one. So we talked about different nodes. So let's take the same example. We have node 0, node 1, node 2. We had something which is called a replication factor. And in that replication factor, because of the replication factor, we had 2 nodes having the same topic, right? And when a producer produces a message to the topic, the green topic, basically, the message also has to be duplicated to our node 0, right? So because otherwise we might lose messages. And that's where acknowledgement comes into place. So if a producer has multiple options of acknowledgement, so the producer can say acknowledgement 0, which basically means fire and forget. So in this case, it fires a message and then just forgets about it. Like it doesn't care. It doesn't care if the message was actually delivered to the master or the leader node. So this is the leader. This is the follower node. And the producer does not really care about that if the message was written to the leader or not. Acknowledgement 1 means leader write has to be successful. So what does it mean is basically the message has to be written into the reader. It has to be committed in the log physically. And until that happens, do not return a success to the producer. Only after that, return a success to the producer. And acknowledgement all means that leader for sure would be written, but also the followers would have the messages. Uh, Followers, and it can be multiple followers. So in this case, what will happen is the producer will produce the message, it will get physically written to the leader, it will get duplicated to the follower, it will get physically written in the log of the follower, and only then the producer would have a success message. Until unless both of these things happen, it will not happen. It will not give you a success. And if any of this step fails, basically the producer will get an error, which would mean that, hey, you know what, your message did not get written, maybe you want to resend it. And this can happen on multiple followers. So in this case, we only had two replication factor. So only node 0 was written, but let's say we had a replication factor of 2. In that case, the message would also be written to node 2, only then it will reply. So how does this actually make a difference? If you are using acknowledgement all, you are basically saying at least once delivery is guaranteed, because you are gonna at least write the message to one. And even if the leader fails, the follower will have the message. But obviously, it's the most slowest way of producing the messages. In case anything goes wrong, you have to rewrite or rerun your code to redeliver the message to Kafka again. But it does have a lot of advantages. We are basically guaranteeing that you will always have the message and you will never lose any messages. Acknowledgement 0 means fire and forget. The messages are not written to the leader. I don't care. The leader writes it and goes down. I don't care. A way between both of this is basically acknowledgement 1, which means that it will wait for the message to be written to the leader, but it will not wait for the message to be written to the follower. What happens if the message was written to the leader and then leader dies? And in that case, your message would never be consumed by anybody. Your message would never be delivered to any consumer. But for you, the message has been produced because you had written it to the leader. But unfortunately, the leader died at exactly the moment the message was getting duplicated to the follower node. It depends upon what kind of messages are you producing, what kind of behavior do you want. So for example, if I want to produce log messages on matrices of like a count of the CPU load, or I don't know, a number of threads in my machine, I would use an acknowledgement 0 or 1. Because honestly, I do not care if I lose a message. I will actually use acknowledgement 0 because that would be really, really fast in writing. And if I'm writing a number of threads or the CPU load every second, I would be maybe even faster than a second, every millisecond, then I'm going to be like pushing a lot of messages out there. So for me, it's way much better to use acknowledgement 0. And if I lose, let's say 10% of the messages, I don't really care. Because for me, this is just a matrix. And if you don't have any matrix for 10 seconds of CPU load, and then in the 11th second, you have the message, that's perfectly fine for the client. But if I'm producing something like rides data, where somebody else is taking some action on the rides, let's say somebody in the payment is reading my rides information, deduplicating it somehow, and then using it to ledger something in the financial statement, which they have to deliver to the tax office later on. And in that case, I would use acknowledgement all, because whatever happens, I do not want to mess paying the taxes. Our company do not want to mess paying the taxes. And in that case, acknowledgement all, although it will be tiny bit slower, it doesn't really matter because your messages delivery is way, way, way much more important than losing a couple of milliseconds on the write side itself. So choose the config you feel most comfortable with. You know your data best because you are the producer, and you should take consideration into what kind of configurations you are using. We talked a lot in this video about different configurations and different terminologies of Kafka. Let's quickly, in 1 minute, recap all of them. We talked about Kafka cluster. It's nothing but a set of nodes talking to each other and running Kafka. We talked about a topic. A topic is nothing but a collection of events. And who creates a topic? Basically, you as a producer creates a particular topic. For us, the topic was rides. For you, the topic might be something different, but it's you who create the topic. Inside the topic, there are messages. The messages have different values, different parameters like key, value, and timestamp. Then we talked about how are the topics stored inside the nodes itself. We talked about the replication factor. We talked what happens when a message is written to, like if a topic has a replication of 2, how the messages are duplicated, what happens if one of the nodes go down, how does the leader follower changes. We talked about retention. We talked about how messages would be deleted after a certain amount of time, which you as a producer can set. This is done for basically housekeeping so that your hard disk does not run over. You can basically say 10 days, 15 days, maybe in a year if your messages are really, really slow. But I will really low, sorry. But I would prefer something like 1 day to 3 days to maybe maximum 7 days, depending upon what you are trying to do. Then we talked about partitions. We talked about how partitions are stored inside the nodes. We talked about how consumers can consume from different partitions. And basically, if you do not have a partition, your consumer would never be able to consume, your multiple consumers would never be able to consume from it. You need to have multiple you need to have multiple partitions so that multiple different consumers can consume and you can parallelize your stuff. So you can only parallelize your stuff by as many partitions as you have. So if you have more partitions, you can parallelize more. If you have less partitions, you can parallelize less. But that does not mean that you always use a partition value of, I don't know, 1,000, because the more partitions it has, the more load it gets on the Kafka cluster itself. We talked about consumer group ID and how consumer group ID plays a role between Kafka and your consumers, telling them that they belong together so the partitions can be divided equally between them. We talked about what happens if we have an extra consumer. So we have a consumer which is equivalent to partition plus 1 or more than the partitions. Basically, it will idle out and it will only play a role if some other consumer dies. Then we talked about offset, how offset plays a role in consumer. What happens if when you have already committed 10 messages or on a message from offset 10. The next time you come to Kafka and say, hey, you wanted to read the messages, basically you will read from message 11 because you have already technically read and committed that you have read message 10. How are these stored? They are internally stored in a topic called __consumer_offset. This topic is already internally created in Kafka, so you don't have to really do anything. Inside the consumer offset topic, you have consumer group ID, topic, partition, and offset. The combination of these 4 actually can tell the consumer and Kafka what messages have already been read and committed and all that. Then we talked about auto offset reset. We talked about what is latest, what is earliest. If you want to consume from the very beginning, you are starting new, you have never consumed anything from Kafka, then earliest is the way to go. Latest is the default, and basically anytime your consumer group ID or a new consumer group ID attaches to a particular topic, it will always by default read from the latest message. So anything which is produced after you have introduced yourself. Then we talked about acknowledgement. We talked about acknowledgement 0, acknowledgement 1, acknowledgement all. Where do we want to use that? Fire and forget, some safety, and but perfect at least once delivery guarantee when you have acknowledgement all. But this is not it. Kafka provides a lot of configurations. So you can already see that there is a topic configuration like deletion retention milliseconds. That's basically the retention we talked about. We are also has flush messages, flush milliseconds. There are also configurations specific to the consumer itself, to the producer configurations also. So compression type, SSL key is basically what we were using, I think, before. And tons of other things which are very specific to producers and consumers. But feel free to go through this documentation from Kafka. If you have any questions, feel free to put them in the video link or connect with me on LinkedIn or on Slack. And I would be really happy to explain to you what that particular configuration means and what would that mean in specific to your use case if you have one special use case, for example. Thank you so much for bearing with me in this very long configuration videos, but I hope this made the terminologies clear to you, and this made it very crystal clear regarding how different things place together in Kafka, how Kafka is built with uh, reliability in mind using retention, scalability in mind using partitions, and some sort of flexibility in mind because you can choose these values, right? You can say, I do not guarantee about, I do not care about reliability. I want to save money. And in that case, you can have a replication of one. It will be only on one machine. And you will only be using one machine's resources rather than the whole cluster resources. And the other cluster can basically do different jobs, like maybe have serving other consumers and producers. You can be super flexible and say, you know what, I'm going to produce a lot of messages. So I'm going to do that in a topic with a big partition. And you can also say that I'm not going to have any data in this topic, maybe 5 messages in a day or a minute. And for that, my one partition is perfectly fine, but I do want reliability. I do not want this topic to get lost and the messages to get lost. So I would have a high replication factor, but a low partition count. And because you can configure all of these values around you, you can configure the deletion, you can configure the partition class, you can also configure how are you connecting to Kafka, what kind of messages size are you able to put into the Kafka topic. You can actually configure Kafka at a topic level or a consumer level or a producer level very easily. And that's where the flexibility parts comes in. But obviously with great power comes great responsibility. And that's why it's really important to understand all these different configuration values when you are either consuming or producing from Kafka. But thank you so much. In the next video, we are going to talk about stream processing. We are going to build one stream processing example, very simple example, doing nothing special. But in the next case after that, we are going to do something a bit more crazy. We're going to do some joins, maybe even use some time strategies to figure out when to do the join itself. I hope you enjoyed this video. I hope you learned from it. Feel free to get in touch with me if you have any questions. And see you next time. Ciao.